Hello everybody and welcome back. Root Beer here, hoping you're doing well. Hopefully you're eager and ready for more of the 2006 Friar Contest. We're going to be looking at question number 3 today. So let's take a look. Alright, question 3. 3 congruent isosceles triangles, DAO, AOB, OBC, have AD equal AO equal OB equal BC equal 10. So we have that provided down here for us. And AB equal DO equal OC equal 12. So we have 3 congruent triangles here. These triangles are arranged to form trapezoid ABCD as shown. Point P is on the side AB, so that OP is perpendicular to AB. So we have a little bit of an altitude right here. Alright, so our questions are likely concerning this arrangement of trapezoids and perhaps another one later on if we're looking ahead. So A, what is the length of OP? Explain how you got your answer. Okay. Well, an altitude for an isosceles triangle, if it hits the side that isn't one of the equal sides, it's definitely going to be perpendicular, and it's going to also be a bisector of length AB. So we can draw ourselves a little bit of a picture, but P is going to split AB in half, is how we're going to solve this one. A, B, P, O, I think it was a D and D and a C here. A, B, C, D was our trapezoid. All right. So since OA is equal to OB, that means that the altitude for the other side, AB, splits AB in half. So then AP is going to be 1/2 of AB, which is 1/2 of 12, which is 6. We have 6 here, we have 10s here, here. This one will also be a 6, 12, 12, and here's another 10. So triangle APO is right angled. So OP, which is the one we want, OP squared, is going to be equal to OA squared minus AP squared. Just a rearrangement of the Pythagorean theorem. That's going to be 10 squared minus 6 squared. And that's going to be 100 minus 36. So that's going to be 64. Or you could just recognize that it's going to be a 6, 8, 10 triangle. And that because it's a... no, I guess we need to explain our answers. I was thinking for a second it might be a light bulb question, but they didn't introduce those for a couple years. So we do actually need to explain what we're doing. So OP is equal to the square root of 64, which is equal to 8. And we've explained how we got our final answer of 8. So that was A part. B, what is the area of the trapezoid ABCD? Explain how you got your answer. Okay. Well, there's a formula for the area of a trapezoid. So if we have a base length of y, a top length of x, and a height of h, we have a formula for the area. It's 1/2 h x plus y. And if you haven't seen this before, it's sort of a basic quadrilateral fact that you likely should have encountered. If you haven't seen it before, you're probably in grades 5 or 6 or something like that, trying an upper level contest, which is a fantastic thing to do, but it might illustrate that you need a little more maths education. The way you can do this is you take this, you duplicate it, you get a parallelogram of base x plus y. And so the formula for an area for the area of a parallelogram with base x plus y and height h is h times x plus y. But we have 2 copies of our trapezoid to make that parallelogram, so we have the total area, and that gives us the area of our trapezoid. Just if you haven't seen it before. And if you haven't seen it before, something you could do is go to an internet search engine and type in area of a trapezoid. I'm sure someone out there has a lovely explanation for it. Who knows, maybe at this point I have a lovely explanation for it somewhere on my channel. Alright. So, we have an area here. Well, fortunately, our trapezoid, we know the base and the height and the top length. So we have a base of 12 plus 12, DO and OC, that's 12 plus 12. We just figured out the height, and we know the top is 12. So the area is going to be 1/2 8 times 12 plus 24. So that's going to be 4 times 36. That's going to be 144. Put a little box around that. So excellent. We have the area of ABCD. Superb. I think there was a C part. Yep. All right. So point X is in the midpoint. Is the midpoint of AD, and point Y is the midpoint of BC. When X and Y are joined, the trapezoid is divided into 2 smaller trapezoids. What is the ratio of the area of trapezoid ABXY to the area of trapezoid, ABYX to the area of trapezoid XYCD? Explain how you got your answer. Okay. So, in order for these to be trapezoids and not just any old quadrilateral, we know that AB is going to have to be parallel to XY, which is going to have to be parallel to DC. AB and DC are already parallel. And X and Y being midpoints, when they intersect, when this line intersects AO and OB, we should also get midpoints. And I think that should be the key to solving this. Alright, so let's redraw our picture and add in X and Y. We have A, we have B, we have C, we have D. Let's leave P in there because I imagine we're going to need to talk about heights. And let's use a brand new color, let's say the yellow. So there's X, and there's Y, and these are midpoints. So it's going to split BC and AD in half. Okay. So each of these is going to be 5. Well, let's get some new points in here. Can't use P. We already have P. How about M and N? So let's let points M and N be as shown. We know that AB is parallel to XY is parallel to DC. And that means that XM is parallel to, I have point O here, DO, and NY parallel to OC. Okay. So this makes triangle AXM similar to triangle ADO. Right? Because these are parallel lines, this angle in here is going to be the same as this angle here, this angle in here is going to be the same as this angle in here, and this was the common angle, so they're definitely going to be similar. And we also have BNY is going to be similar to BOC. So the side's in the ratio 1 to 2. Right, the side length BY, we double that to get its corresponding length BC. So side length BY doubles to give us BC. So in this way, we can see that M and N are going to be midpoints. So we get a 5 here, and a 5 here. We still have 16 here and 16 here. Or sorry, not 16. I have no idea what I'm saying. 12 here. Still have a 6 up here and a 6 up here. Okay. All right. So we know M and N are midpoints. But M and N is also parallel to AB. So this shows that triangle OMN is similar to triangle OAB. And once again, the sides are in the ratio of 1 to 2. Okay. So that's looking good. So one thing we can notice is XY is going to be a half DO. So that's going to be 6. No, sorry, not XY. XM. MN is going to be 1/2 of AB. So that's going to be a half 12. That's also 6. And NY is going to be a half of OC, which is also going to be 6. So now we can figure out the length xy. And that's crucial for finding the area of both these two trapezoids. What else do we need? We also need the height. So xy is going to be 18. Let's define ourselves a new point, Q. He's going to be on OP and MN. So OQ is going to be the height of our bottom trapezoid, and PQ is going to be the height of our top trapezoid. So if the sides have ratio 2, all lengths that we can compute are going to have the ratio 1 to 2 if they're similar to each other. All areas will be 1 to 4. So that means that QP is OP minus OG, not OG, OQ. That's going to be 8 minus 4 is equal to 4. And that means that ABYX has base of 18, top 12, and height 4. And that gives us an area of 1/4 for 12 plus 18. So that's going to be 2 times 30. So it's going to be 60. And XY CD has a base of, it's still going to be 12 plus 12, which is 24. Top's going to be 18. And a height of 4. And what area does that give us? 1/2 height times the sum of the base and the top. So that's going to be 2 times 18 plus 24, so 2 times 42. So that should be 84. Now, I believe we were asked for the ratio or the fraction of these two. What's the ratio of the area of trapezoid ABXY to the area of trapezoid XYCD? ABYX to XYCD. That's 60 to 84. But both of these have a common factor of 12. This is going to be 5 to 7. So 5 to 7 is our final ratio between the two of them. And I think that's all we were asked for, just the ratio. Alright, so let's take a look at how exactly we did that part of the question. So we used the fact that they're trapezoids to show that XM, NY, and eventually MN are parallel to AB and DO, OC, and DC itself. And that allowed us to realize, well, MN are going to be midpoints, Q is going to be a midpoint of OP, And that really allows us to compute these lengths, xm, mn, pq, qo, and ny. And that gave us enough information to compute bases and heights and tops for these two trapezoids, which allowed us to then give the ratio of their areas. So that's a nice little question. Hopefully you enjoyed it, and I'll see you guys for question, what was this, question number 3? Yeah, so we'll be on to question number 4 in the next video. I hope to see you guys then.